so here's some from our mixed practice. So let's start with number 6. What did you need to use for number 6?
Chain rule.
Chain rule, okay? We have something cubed. So the derivative of something cubed is 3 times the something squared, okay? Now, just make sure that this all stays the same when you're doing this part of it, okay? That is, if you remember, we did dy du, and then you've got to multiply that by du dx, and u is that inside function. So this is the derivative of the function with respect to u, with respect to that inner function. When you see this part right here, this is the part that doesn't change when you take that derivative. Normally we're doing dy dx, all the x's are just x's, and that'll make even more sense later on when we do what's called implicit differentiation, and that's where we're going to be finding the derivative with respect to x, but there are going to be other y's in there, or other variables in there that we have to consider. So this is just the dy du. Then we need to multiply that by the derivative of this inner function. So 12x squared minus 10x plus 10 plus 0. Okay? And the only simplifying that you could really do, or you might really do there, depending on how you think about simplifying, you could either factor out a 2, so it's more factored, or if you wanted to distribute the 3 inside, you could simplify by having fewer things, okay? Probably given what we're going to be doing in the near future, if I saw something like this, where I had a common factor in here, I would probably just pull it out, and now I'd have a 6, and this would be a 6x squared minus 5x plus 5. Okay, but again, that's just in light of, I know where we're headed with all of this. We're going to be then trying to solve when this would equal 0. So that's number 6. Does that make sense?
Yes.
All right.
And for the test, you'd like us to leave it like that? Is there like a preference for?
Yeah, you can leave it like that.
Okay.
So, let me do number 8. Okay, number 8. Again, we have the chain rule, but this thing it's to the -8th power. So, the one thing you got to be careful with this is when you subtract 1 from the exponent. This is probably where a number, if you messed up, then this is probably a really likely thing. Okay, we pull the -8 out in front. We have the 4t minus 3, but now it's to the -8 minus 1 power. So now it's to the -9th power. Okay, so the -9th power. And then we also need to then multiply by the derivative of the inner function. The inner function is 4t minus 3, so it's just times 4. Okay?
Could you distribute like the negative, -8 to it also, or no? You get up like to the 4 minus 3.
Can someone answer that? Can we distribute the -8 here?
No, because since it's the negative exponent, that means that that's going to actually present itself as -8 over 4x minus 3 to the 9th. And you can't distribute it.
Yeah. And really, even if it weren't negative, I mean the negative especially there, but even if it weren't negative, if this is raised to a power, you can't distribute into it. Because your order of operations says you have to simplify that power before you can do
And
multiplication.
that's going to be tedious.
Yeah.
Wait, but didn't we do it in the previous one? Like,
I factored out of this, but notice here, it was just the first power. I couldn't have factored out of this with the square, and I couldn't have distributed the 3 into this set of parentheses. If I were going to distribute the 3, it would have had to be to this.
Oh, okay. I thought you were talking about different. I thought that you were talking about like you can multiply -8 by 4.
Oh, yeah, I can do that, because this
Okay.
is all multiplication, so I can rearrange that. That's a
Okay.
minus 32. And since that's a negative exponent, I'm going to put the 4t minus 3 to the 9th in the denominator, and that would be fully simplified.
Okay.
All right, number 12 was the other one that was asked about here. This one, we just have to be real careful with our radicals and translating those into exponents. Okay. What I would do first of all, well, the very first thing is I wouldn't let the fact that I wouldn't let the fact that I have x of r as my fraction mess me up, okay? X is like the f, and r is like the x, okay? R is our independent variable. In this case, x is the dependent variable. And that's okay. All of our points, if we were to graph this, would be the points r, x. And I know we're not used to dealing with that, but that's okay. Alright? So the first thing I would do though here is I would rewrite this. And I'd rewrite it using all fractional exponents. I would say, okay, well this would be 3 r to the 1/3 power, because it's a cube root. And I'd do a minus, and I'd actually split this up even, root 3 times r to the negative 1/2 power. Okay. It's negative 1/2 because it was in the denominator, that's what made it negative, and it was in the square root, so that's why it's the half. And then here, I would do this plus 1/3 r to the negative 1 power. Okay?
Could you also put 3, no, never mind, I answered my own question. Because I was thinking 3r to the negative 1, but wouldn't that read as 3 over r?
Well, if you wrote it like this, yes. If you did this and then used the chain rule, you could do that. Okay, but then you have to use the chain rule.
Exactly.
So it's
More efficient to do it that way.
so now we're just using our rule for the power here. 1/3 times 3 is just 1. But then I need to subtract 1, so 1/3 minus 1 is a negative 2/3 power. So here I'm doing x prime of r is 1 r to the negative 2/3 power. Here I need to bring the negative 1/2 out in front, so now it's a plus, and that'll be root 3 over 2, r to the negative 3/2 power. Because I subtract 1 from the negative 1/2. And then here I bring the negative 1 out in front, so it's a minus 1/3 r to the negative 2nd power. I would go ahead and simplify all the negative exponents. You don't need to necessarily write them as radicals again, especially when it's 2/3, because you'd have to, I mean, if you were going to write this in a radical, you'd have to put 1 over the cube root of r squared. Okay, so rather than mess with that, we'll just do 1 over r to the 2/3 power plus root 3 over 2r to the 3/2 power minus 1 over 3r squared. And I'd leave my answer like that. Okay? So that was, again, number 12.
When we got The 3 again, how?
We got the 3, the
Or
3
no,
was
the-
just from here.
Oh, no, pardon me. You know how we go from 1/3 to -2? That's, where'd the 3 go?
Because we had to multiply, we had multiplied by the exponent, so 3 times the third.
Gotcha,
Okay.
thank you.
Any other questions? Okay. Other problems that you had trouble with, or anything? All right. So